Hey Calc class, so here is our next lesson. So far this week we focused on rotating a region about the x-axis. Today we're going to move into the y-axis. Alright, pause the video. Here's a practice multiple choice. This is a little tricky, you have to really think about it. So when I looked at this, I started with the limit, right? The limit as x approaches 2 is not equal to 0. Well, if you plug in 2, from the left, from the right, this one works. So it's not, which of the following is true? This says not, it is equal to 0. Is the function continuous? So that's the next thing I looked at. Well, it is. Because of those absolute values, I thought of it as if I plug in numbers to the left, it's basically like the limit, right? Does the limit is 0, right? Is there a hole? There's not a hole. So the function is continuous. Vertical asymptote. This is a square root. There's no reason why this would have a vertical asymptote. So now here's the question. Is this differentiable at 2? It is not. So the answer is A. And here's how I thought about it. If I just had the square root of x minus 2, right, that looks like that. Because of the absolute value, though, what's happening to it's also going to go to the left. So if I plug in 1, I get 1. So this one, so it's going to be like that. There's going to be a cusp there because of that absolute value. So that's why it's A. And this is not a calculator, so you can't just put in your calculator and look at it. All right, find the volume of the solid generated by revolving the region bounded by the graph of x cubed, the y-axis, and the lines y equals 1 and y equals 8. All right, so there's my graph. That's x cubed. Y equals 1 is here. Y equals 8 is here. So this is the region we're rotating. Okay, so if I reflect that over, this is my region. All right, so it's this weird, again, cone-shaped thing. All right, so because we're rotating around the y-axis, we need everything in terms of y. So if we have y equals x cubed, okay, let's turn that into a 3. That means x equals the cubed root of y. So this is flat up against the axis, so we don't have to worry about subtraction or anything like that. So we got pi. Now, because we're doing this in terms of y, what are our bounds? Well, they literally gave them to us, 1 to 8. The cubed root of y squared dy. So that's pi from 1 to 8, y to the 2/3. We can do this without a calculator. So that's pi times y to the 5/3, 3 over 5, from 1 to 8. 3 pi over 5 times, let's see, 8, the cubed root of 8 is 2. 2 to the 5th is 32, minus 1. So that's 31 times 3, so 93 pi over 5. Right. So that's about as basic as you can get. Flat up against, it's rotating, making this weird cylindrical thing. All right, we actually did this one before, but now we're doing it in terms of y. So this was like on our Monday lesson, I think. So we have y equals 2x, y equals x squared. So we have our x squared, 2x. And we are rotating that about the y-axis. So this one will have subtraction in it because we've got our cone, right? We've got the outside and then the inside. Outside, inside, outside, inside. I was watching a Khan Academy video and I was like angry at how good they are at drawing these. It hurt my feelings. All right, so we need our bounds. So where do these intersect? They intersect at 0 and 2, 4. So keep in mind our bounds. We're integrating from 0 to what? 4. Don't forget you're using your y value. Pi. Now we need our big R. So our axis of rotation is the y-axis. How far out are we going? Well, the farthest thing out is our x squared, which is, if x squared equals y, x equals the square root of y. So this is our square root of y. So square root of y squared minus our inside function. So this is our little r. All right, so we got our big R, little r. So big R is the square root of y. Little r is y equals 2x, so we're going to solve that for x. X equals y over 2. So y over 2 squared. All right, I'm going to simplify this. Pi 0 to 4, it's an ugly pi. Y minus y squared over 4. Again, we can do this without a calculator. It's good practice. Y squared over 2 minus y cubed over 12. Pi from 0 to 4. Okay, I can't handle how ugly this 4 is. It looks like a 6. I don't even know what that looks like. Nothing. All right, so we got pi times. So when we plug the 0 in, we get 0, so that's nice. So 4 squared is 16. 16 over 2 is 8. 64 over 12. Ugh. All right, so let's see. I never filled this in. Y over 2. All right, so 64 over 12 divided by 4. And I get 16 over 3. So this is 16 over 3. 8 is 24 over 3. So we get 8 pi over 3 is our final answer. That is not that hard. We can do it without a calculator. Man up, guys. It's kind of a sexist thing. I'm sorry. I take that back. All right. That was my notebook because I need to check my answers because I make silly mistakes with these constantly. All right, so this is a practice AP problem. Pause the video, read it. What do you think? The volume of the solid generated by revolving the region bounded by y equals sine x equals pi over 6, and the x-axis about the y-axis. So the fact that we're rotating around the y-axis, automatically I can take out A. Because that is in terms of x. Like, no. And I can also take out something else. They just magically replace the x with y in D. Like, notice it's still pi over 6, but sine squared of y. You can't just magically, it's not, we're not doing the inverse, so it's not going to be D either. So we have to decide, is it B or C? All right, so I'm going to draw my picture. So we have sine. We have pi over 6 and the x-axis. So this is my region, and we're rotating it this way. So we got that. Doot. These make me mad. I was so good when I did this with chalk. It kind of irritates me. So it's like a cylinder with like this weird hole, like with a cone like scooped out of it. That's what it looks like. All right, so we need our big R, little r, right? Because there's a gap here, what's our big R? Our big R is pi over 6, right? That distance is our pi over 6. Little r is this distance. That's the sine curve. But we have y equals sine x. We need this in terms, we need to solve for x. So x equals arc sine of y. So we have a big R and a little r, which means our answer is going to be B, right? We have our big R squared minus little r squared, B. All right, I want you to pause the video and try to figure out what this graph looks like. I think this one is the most difficult because it's not something we graph very often. You really have to go back to pre-calc for this. So if I have x equals 4 minus 4y squared, x squared equals 4 minus 4y squared, x squared plus 4y squared equals 4. So do you know what that looks like? Divide by 4. That's x squared over 4 plus y squared equals 1. This is an ellipse. Now, when I did this problem, I messed up my graph, so I messed up my bounds. We need to know what this looks like for us to accurately graph it. So the radius of this thing for the x side, it's going out to 2. And the y is going out to 1. So I graphed this thing wrong, and I did it as a circle accidentally. I did 2, 2. And so my bounds were messed up. So it says we have x equals the square root of 4 minus y squared. So we actually only have half this graph. X is positive, so we can erase the side that has the y. The x is negative. So that's actually our graph. But here's the thing, we're rotating around the y-axis. So it's going to be this like cone-shaped thing anyways. Ugh, I can't draw, guys. I'm sorry. It's this weird, it's like almost a sphere, but it's elliptical thing. I don't know. What do you call that? My brain doesn't work. All right. But here's why we needed to know what it looked like, because we needed the bounds. So what are the two y values? It's going down from -1 to 1. And I could not figure out why I kept getting this problem wrong, because it's not that hard, but I messed up my bounds. All right, so we are integrating. It's flat up against the y-axis, so we don't have to worry. Squared dy, which is nice. So it's pi -1 to 1, 4 minus 4y squared. So we get pi times 4y minus 4/3 y cubed from -1 to 1. So pi times 4 minus 4/3 minus, another bracket, -4 plus 4/3. And don't be a baby, you can do this in your head. So I have 4 and +4 is 8, -8/3. That's 24 over 3 minus 8 over 3 is 16 over 3. And then don't forget your pi. It's not that hard to do that in your head. You can do it. The hard part was figuring out where this equaled 0. So if you couldn't figure out the bounds, what you also could do was just say, okay, so what are the x values of this graph? Or what are the y values? So let x equal 0. So if you do 0 equals the square root of 4 minus 4y squared. So where does 4 minus 4y squared equal 0? 4 equals 4y squared equals 1, so y is plus or minus 1. So I shouldn't have struggled with it, but I did in terms of finding the negative 1 and 1. All right, last problem. All right. The volume of the solid generated by revolving the region bounded by the graph, the square root of x, y equals 2, and the y-axis, about the line x equals 4. Okay, so now we are not rotating around the y-axis, but we're rotating around a vertical line. So let's look at this graph. So we have the square root of x, we have y equals 2, and we have x equals 4. And the nice thing is the two lines they give me do meet up, right? Because this is the point 4, 2. So this is my region, because it's the y-axis. And we're rotating around this line, so it's going around like that. Okay. So it's like, I'm off the graph. But then there's a hole, right? Okay, so what is big R? What is the distance from my axis of rotation all the way out? That's my big R. Well, that's just 4. What's my little r? What's the distance from here out? So, sorry. This distance is our y, right? That's our function. So that means, in this whole distance, the green distance is 4. So our yellow is going to be 4 minus the function. Now we have to take our y equals x square root of x and solve for x. Y squared. Basically, just like on the other ones, it's instead of up minus down, it's right minus left. So we're going to take our right function, which is the line, and then subtract off the this blue function right here. I had it black before, and that will equal yellow. Right? Green minus blue equals yellow. So now let's set this up. 0. What's the y value? 2 pi big R squared, which is 4 squared, minus little r squared. Now this would not, you can do this, but this looks like it's not a calculator problem. Notice the answers. So you cannot integrate this second piece, so I'm going to multiply it out. So I get 16 minus 8y squared plus y to the 4th. So when I simplify this, the 16s cancel out. I get 8y minus y to the 4th. Another one I just made like the silliest mistakes with, guys, and a y squared, sorry. Yeah, I dropped my squared, and so when I was trying to do this earlier, I got the wrong, I got an answer that made no sense. It was negative, and I was like, what did I do? Because I dropped the squared here when I multiplied out. All right, so we get pi times 8y cubed over 3 minus y to the 5th over 5. I'm sorry, I keep awkwardly coughing. All right, so let's plug the 2 in. The nice thing is when we plug 0 and we just get 0, so we only have to deal with the 2. So that's 8 times 8, so 64 over 3 minus 32 over 5. So multiply. So one thing that you can do if you want to make, if you don't have a calculator, right? Both of these numbers are multiples of 32. So one thing I do sometimes is I'll do 32 pi. I'll factor out the 32. Then I have 2/3 minus 1/5. That's easier to turn into a fraction. So that's 15, 10 minus 3, so 7. So 32 pi times 7 over 15. So 15 on the bottom, and then 7 times 2 is 14. Carry the 1, 224. So it's B. And we're done. It's only 4 problems. You can do it. Email me if you have questions. Oh, I have to draw someone. Who should we draw today? Generic. Let's say it's Meow. It's Meow today. I hope some random person watches this video and like, who's Meow? Oh, but he has to get a 5. Have a great day, guys.